All right, we're going to continue with R3. That's why it's R3B. Let's see. We did the example. We did the 3, 4, 5 triangle, correct? All right. And I said there's some other special triangles, but we're just going to stick with the 3, 4, 5 right now. Okay, here's a question that they could ask you. They call this the converse of the Pythagorean theorem. Where's that name Pythagorean come from? Pythagoras. Very good. I used to remember a little bit about Pythagoras. I haven't done any kind of study on him or anything like that, but I did Google him just to find out some stuff. But he actually, from what I understand, he didn't actually come up with the Pythagorean theorem, but he was the first one to prove the Pythagorean theorem. They knew about the Pythagorean theorem like long before Pythagoras, but they just accepted it was true. But he actually came by and he actually proved the theorem. And there are proofs for it in a lot of math books, maybe even this math book. But at our level right now, I'm not going to worry about proving it. Okay, maybe when you get into college or something, or if you're like in a calculus or pre-calc class, you might prove it. But he's the one that actually proved the theorem. Just simple little fun fact. All right, so here's what the converse says. The Pythagorean theorem says this. It says, if you have a right triangle, then a squared plus b squared equals c squared. Okay? Everybody understand that? So if you have a right triangle, if you square the legs and add them up, it's going to equal the square of the hypotenuse. Did you know, have you ever watched, what's the Dorothy one, long time ago, The Wizard of Oz? You ever watch The Wizard of Oz? Anybody? There's a part, you remember the scarecrow gets a brain? Okay? Well, he rattles off, and I used to show this. I used to have this clip ready to go, but I don't now, but you could look it up. But there's a clip when he gets real smart, he rattles off something, some like math stuff, and it's supposed to be the Pythagorean theorem. But if you listen to what he says, he actually is not 100% correct on it. So that's kind of interesting. You'd think there would be somebody there that would know exactly what the Pythagorean theorem was. But he said something like, he's all, kind of silly and dumb and stuff, and he gets his brain, he's like, all smart. And he's like, oh, the square of the hypotenuse is equal to the sum of the squares of the legs. Or he says something like that to make him look real smart. But technically, if you listen to what he says, and I forget exactly the wording, but it's not quite exactly right. So it's just kind of interesting that he gets a brain, but even us without a brain gets things wrong sometimes. And so did what was he? Scarecrow? Is that what he was? Yeah. All right, so what does the converse of the Pythagorean theorem say? So it's basically, you take the if and the then, you switch it around. So the theorem says, if it's a right triangle, then a squared plus b squared equals c squared. So what do you think the converse is? If I switched it around, we would say what? If a squared plus b squared equals c squared, so let's write this down. So if, I'm going to write the c first though, is that all right? If c squared equals a squared plus b squared, there's a reason for that. I think we get into it. No, we don't, but I'm gonna talk about it anyway. If c squared equals a squared plus b squared, then what kind of a triangle do we have? Then, well, I'll just say it's a right triangle. A right, and then I'll put the symbol for triangle. That's the symbol for triangle right there, okay? So if you have three sides, you have a three-sided polygon, and if you take the longest side, okay, the longest side is always represented by the C. If you take the longest side and if you square it, and if it equals the sum of the squares of the other two sides, do you hear what I said? It sounds like a little gobbledygook, but it makes sense. The sum means what? Add the square of the other two sides, right? A and B are the other two sides, and I've squared it. Does that make sense? So what is this? This is the hypotenuse squared is equal to the sum of the squares of the other two sides. That's another way to say Pythagorean theorem. And that's kind of what the scarecrow guy said. It wasn't exactly, but it was kind of what he was supposed to say anyway. So if you have that situation, then it's a right triangle. All right? So if I gave you the sides 5, it's a weird looking 5. Let's make that a little bit better. 5, 12, and 13. Okay? If I gave you those sides, you have to determine, is this a right triangle or not? Well, how do you do that? Well, you're going to use the converse of of the Pythagorean Theorem to figure that out. What does C represent? The longest side. So which one is the longest side here? 13. Now, what do you do to it? Square it. What I'm going to do, I'm not going to put equals just yet. I'm going to put a question mark instead of an equals because I'm not sure just yet that these are going to equal, okay? Because I don't know if it's a right triangle or not. Actually, I kind of do. But in theory, I don't know if it's a right triangle. So I take 13 and I square it, and then I take the other two sides, the 5 and the 12, I square those, and then I do what to them? I add them up. So I put a question mark there because I don't know if they're equal just yet. I got to do a test. This is basically a little test to see if these three sides make up a right triangle. Because you can't take any three sides, any lengths at all, and make a right triangle out of it. Okay, they got to be a certain lengths to be able to make a right triangle out of it. So let's see if it is. Does anybody know what 13 squared is? Nana, you got your calculator out. What is it? 169, right? Okay. I'm going to keep that blank. I'm not going to put a question mark. I'm just going to leave it blank. Let's do the other ones. What's 5 squared? It's 25. Plus, what's 12 squared? You know that. 144. So now, does 169 equal 25 plus 144? Doesn't? Add them up. Yeah, the 4 and the 2 is a 6. The 5 and the 4 is a 9, right? So that's 169. So they do equal each other. I'll put a little check mark next to it. Because again, we're just trying to test to see if those three sides make up a right triangle. Okay, do they make up a right triangle? Yes, they do. Okay, this is another one of those special right triangles. I mentioned the other one earlier today. What was that first special right triangle? What were the sides, the three sides of our special right triangle? 3, 4, 5, right. So one of our special right triangles is 3, 4, 5. What's another special right triangle? Well, you could go 6, 8, 10. You could keep doubling all along, but I want to go right down to the basics where you don't have to divide it by anything. So it would be what? What's our other one? We just did one. 5, 12, 13, right. There's others. I can't think off the top of my head with the other one. There's like an 11 and a 17 in there somewhere. I forget what it was. But anyway, these right here are pretty popular special right triangles. So again, we talked about if you took a SAT test, correct? Or SAT test. It's kind of redundant, but an SAT, they might give you this. They might say, this is 13, this is 12, solve for x. Do you have to go through the whole Pythagorean theorem to figure out what x is going to be? You shouldn't have to, because these are the two sides of my special right triangle. So what is the other side? If one of my legs is 12 and the hypotenuse is 13, what's the other leg have to be? It's got to be 5. That's right. So that'll save you a couple minutes, wouldn't it? On a test, especially if it's the SAT and it's a timed test and you got to finish in a certain amount of time. And it's hard to finish those in the correct amount of time. All right? So if you look at it, you're like, oh, that's just 5. Bam. You got it right. You go on to the next one. Okay? Same thing with 3, 4, 5. You could even double it, right? You could say that this was 26 and this was 24. What would this side be right here? Without doing much math at all. What would this length be right here? If this was 24, this was 26, this would be what? 10. Because all I did was just double them, right? Make sense? So you could see that on a PSAT or a SAT, right? And if you do, I want you to come to me and say, yo, Mr. Hamrick, I took that test and I saw that special right triangle on there, all right? Promise me? Sure you will. All right, enough of that. I was going to say something else. I'm not going to. I would just take too much time. I got too much to do. All right, here's what we're going to do. Wow, he's actually got a couple of these on the back board right here. So what we're going to do, we're going to do some geometry. And we said this thing is, I think this lesson was called Geometry Essentials or something like that. So these are some geometry formulas that would be really nice to know. But guess what I'm going to do? I'm going to take it super easy on you on a quiz or a test. Guess what I'm going to do? I'm going to give you the formulas, okay? But you got to know how to use them. You got to know what everything stands for and all that kind of stuff, all right? Because to tell you the truth, in the real world, if you're going to try to figure out what the volume of a cylinder is, right? You could Google what the formula is, right? And so you could find it, all right? So I think like memorizing some things like multiplication tables, I think that's important. I really do. Okay, even though you have a calculator, I think it's important to be able to do stuff like that. But these geometry formulas, I'm going to show you what they are and what they mean. I just want you to be able to use them, all right? Because I do think we have either a quiz or a test where I give you a whole sheet of a whole bunch of formulas, all right? But you got to know what they stand for and you got to know what they mean. So let's do the first one. Let's find, I think we're going to do a couple things. Let's do a couple things with rectangle. A lot of times books will, they'll start off with like perimeter and they'll give you the perimeter of all these different shapes, okay? And then they'll go to area and give you all these different area formulas for different shapes. This time, they're going to give you the shape and they're going to tell you what the perimeter is and what the area is of that particular shape. Does that make sense? All right, so a rectangle. There's a rectangle right there. Okay? A couple things we need to know about it. A rectangle, the two opposite sides are equal to each other and the other two opposite sides are equal to each other. That's what's unique about a rectangle, okay? So one of the sides we call the length and the other side we call the width. It doesn't really matter which one you call the length or the width. Most of the time we would probably call the length like the longer one, okay, than the width the shorter one, but it doesn't make any difference, all right? So as long as you call one letter and one the other letter. Sometimes books will say that this is the base and this is the what? The height, okay? It all depends on what book you use, what they, what terminology. We're going to stick with length and width right now. Is that all right? All right. So what we want to do is let's find the perimeter. What does perimeter mean? I'm going to put this in parentheses down here. Well, the perimeter just means the distance around that figure. I'll just put distance around, okay? So the distance around it. So if I knew what this length was and I knew what this length was, I should be able to find the perimeter of that whole thing. I don't have an example written down here. Let's see. Maybe I do. Nope. You kidding me? I don't know. Are there any examples in the book? Anybody have the book open? We can make one up. Let's just make it up. Let's do this in a different color. Do it in red. Give me a good length for this. Nothing crazy. Give me something. 21. Okay. I tell you what. Let's go smaller because we're going to do area in a minute. It'll be a lot easier. 8. Okay. Let's go 8. What do you think the width is? 5. All right. So there we go. So if I asked you what the perimeter was, I'll just put P for perimeter, capital P. All right. If I asked you the perimeter of this, you don't have to memorize a formula. You can just do what to it? Gage? You don't like that color? You can't see it? Well, my goodness. How's that? All right. We know that's 8 and 5, right? You okay with that? All right. So if this is 8, then what's this side up here opposite that 8 going to be? Right, because on a rectangle, the opposite sides are equal to each other. We good? If this side is 5, what's this side over here going to be? It's going to be 5. Now, to find the perimeter, how do we find the perimeter? Just add them all up. That's right. Okay, it's the distance around it. Okay, if I was walking, this was a football field, and I wanted to find the perimeter of the football field, what would I do? I'd start here. I'd walk this way, right? Figure out how much I walked. I walk this way. I don't even know what is the width of a football field. Is it 50? Exactly 50? All right. So this would be 100, this would be 50, this would be another 100, and this would be 50. All right, so what would that be altogether on a football field? That's 200, and that's 100, so it's what? 300. So if you walked the perimeter, if you ran the perimeter of a football field, okay, you would go 300 yards. With me on that? All right, on this particular thing, it's just 8 and 5, whatever it is, centimeters, inches. Let's make it something. Let's make it centimeters. Okay, so let's make it all centimeters. Because when you measure something, you always measure with some kind of unit, right? Measure it in feet, in yards. In football, you measure stuff in yards. I played disc golf. I played it yesterday. Oh, I had my best score yesterday. I had a +1 at Brantwood Golf Course, and I think my highest before that was like a +5, so I did much better. So I was so excited. But anyway, they measure everything in feet. In regular golf, they measure it in what? Yards. Like the hole is this many yards. Because a golf ball, you can hit a lot further than you can throw a disc. So in disc golf, they measure it in feet. So you always measure in a certain unit, okay? So we'll just call it centimeters. So let's do this. How do we find the perimeter? Well, what did I just do right here? 8, there we go, plus what? 8 plus 5 plus 5. Now, there will be, and this book does it, okay, and I thought they did. Watch. You could have just done what on a rectangle? You could have just said 2 times what? 8. And you could have gone, what, 2 times 5. So the book writes this. The book writes the formula is the perimeter is twice the length plus twice the width. But I think, to tell you the truth, it's a waste of time to memorize that, because all you got to do is know that if this is 8, this is 8, 5 and 5, and then just add them all up. Would you agree? A lot of people get confused on the formulas, right? 2L plus 2W. Oh, I can't remember if that's... If you just remember what perimeter means, just the distance around it, then just add them up, all right? That's what I would do. So let's just do that. 8 plus 8 is 16, and 5 plus 5 is 10, and that is 26. So the perimeter. Do I just write 26 and circle it? No. It's got units, so you got to put the units. I know some teachers that are very, very picky on that, all right? And they should be, because if you do it in, if you measure it in certain units, you can't just take 26, because it could be 26 feet, it could be 26 miles, all right? It's not. It's centimeters, so it's 26 centimeters. Pretty easy, right? Yeah, that's easy. Let's talk about something else. Can you see this pink or not? Is that better than the red? Okay. Let's talk about something else. Not perimeter. What's the other thing we're going to talk about, do you think? We'll do it up here. Yeah, area. And what in the world is the area? Well, the area is basically this. If I like, I'm not going to do this because it's going to get really messy. But if I divided this into 1 centimeter squares, right? If I put a line here, 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 8 times, right? And then I did 5 of them right here. And then I had perfect squares in here. You follow me? How many squares would you have in this box? So I got, what, 8 going this way, right? I got 5 going this way. So how many perfect 1 by 1 centimeter squares am I going to have in that rectangle? I'm going to have 40, right? How did you do that? You just took the length and multiplied it by the width. You follow me? So on a rectangle, again, this is all rectangle. The area is the length, I'll put a dot, times the width. All right, so on an area, you multiply. So let's do it. Let's use the same numbers, 8 and 5. So the length is 8 what? Centimeters, times the width, which is 5 centimeters. And you said it was what? 8 times 5 is 40. What about the units, though? Is it just going to be centimeters? Remember, we're finding how many squares are in that big rectangle, correct? How many squares are in there? There's 40 squares. So the centimeter is going to be what? Squared. Let me show you why. Because what's centimeters times centimeters? What's anything times itself? It's always something squared. 2 times 2 is 2 squared. 10 times 10 is what? 10 squared. Centimeters times centimeters is what? Centimeters squared. You got it? X times x is x squared. So that's why it's centimeters squared. I'm telling you, students get so confused on whether it should be centimeters or it should be centimeters squared. Area is what? Finding out how many what? Squares are inside this box. So your units should be what? Squared. If you walk around something, if you walk from one end of the football field to the other, you haven't walked 100 square yards, have you? You've only walked what? 100 yards. Make sense? So distance, perimeter, is just whatever the units are, okay? Whatever it is. Inches, feet, yards, miles. Area is always how many squares can you fit inside of that figure. So your area is always going to be centimeters squared. We good? You'll see this sometimes. Like if you go, when you get older, you might buy some carpet or something, right? And if you look at the price of the carpet, it's like $5 per square yard. I don't know what it is today running. It's probably way more than that, okay? But you'll see this. You'll see that SQ, square yards, that's the exact same thing as just saying yards squared. You with me on that? All right, so if you go somewhere and you buy something, okay, you'll probably see square yards or square feet or something like that. It's the same thing as this. But in math class, we write it like this, and we don't write the SQ. We write the actual exponent, okay, yards squared. Make sense? We ready to go on? All right, so we did a rectangle. So that was perimeter and area of a rectangle. What do you want to do next? We could do a triangle. Yeah, okay, let's do a triangle. I was going to go to circle, but yeah, triangle is a much better one to do. Can you see the blue? Oops. Is blue all right? Yeah. Okay. Let's draw a triangle. I'll draw one the way the book does it. I'm going to try to make that look like a right angle right there. And I'm going to connect this to this. I purposely made it into a right triangle for a reason. Okay? Now it's a right triangle. Before I put that box there, did you know it was a right triangle? No. All right? Now it's a right triangle. So let's write this down. So we want to find, I'm not even going to talk about the perimeter of a triangle. It's the same as a rectangle. All right? So what do you do with a triangle? You just do what to all three sides? To find the perimeter. Come on, talk to me. Yeah, we just did it. How do you find? You just add them up. Right, exactly. Okay? You just add up all the sides. Same thing with a rectangle. I'm not going to put any kind of formula. You just add up all the sides. No big deal. Okay? So what I'm going to concentrate on right now is finding what? The area. Okay? The area of a triangle. Now, we have a formula. I'll tell you what. Let's do this. I'm going to show you where that, oops, that's not what I wanted. I wanted this. I'm going to show you where that formula comes from. A lot of teachers don't do that, but I kind of like to do it. Here's a rectangle. Remember, we called it length times width, but we could also call it what? Base times height. Would you agree? Let me show you where this formula comes from. If I drew a line from this corner to this corner, I basically split that rectangle into what? Into two triangles. But what's true about those two triangles? They're exactly the same, right? So really, I took the area of that triangle and I split it what? In half. Would you agree? So one of these triangles right here is exactly how much of the rectangle? Half of the rectangle. So do you remember what the area of a rectangle was? Let's use B and H instead of L and W. It's base times the height. So what do you think the area of a triangle is? So area equals, it's not base times height, because that's the area of a rectangle. Okay? So what if I wanted to find the area of all this? How many squares can you fit inside of that area right there? Okay? It's half of it, exactly right. That's how they get the 1/2 on area of a triangle. All right? Do you remember that formula when you were younger? Base times height divided by 2, or you could write it how? 1/2. Oops, what did I just do right there? We could write it 1/2 times the base times the height. So either one of those you could look at as the area of the triangle. Does that make sense? The base and height, good question. Right here, look at the base and height to this. The base and height, let me do a different color so it stands out a little bit. Okay? So if I have the base and height of this triangle, what kind of an angle does a rectangle have? It's got a right angle there, doesn't it? Okay? Now notice, it's very important. The base and the height have to be a word. I don't know if I used this word before, but you probably heard it in geometry. They got to be perpendicular. What does perpendicular mean? It means two lines that form a right angle. All right? The base and the height have to form a right angle to each other. So look at this triangle right here. All right? Which sides would be the base and the height? Right. This side right here could be the base, or you could call this side the base. It doesn't matter. So if I call this the base, which one? The one on the right or the one on the bottom has to be the height? The bottom? Remember, the base and the height have to be what to each other? They got to be perpendicular. So this line is perpendicular to this line, so this has to be what? The height. It doesn't matter which one you call what. You're just going to multiply them together anyway, right? So it doesn't matter which one. But one's called the base, the other's called the height. This cannot be the base or the height. What do we call this side right here? This is the hypotenuse. I'll just put HYP so you don't get it confused with the height, okay? This is the base and this is the height. It's very important on triangles that you know which one is which. Everybody got it? It's the two that are perpendicular to each other. Okay? All right. So let's put some numbers in. So let's get rid of that. Let's get rid of that. Let's get rid of that. And I asked you to find the area of this triangle right here. Let's just say that's 3, and let's say that's 8, okay? This is about as easy as area of a triangle can get right here, okay? It gets more complicated. This is about the easiest version that you can see. If I ask you for the area of this triangle, again, what is it? It's base times height divided by 2, or 1/2. I like this. I like base times height divided by 2. It's the same thing. It means the exact same thing, right? Dividing by 2 is the same thing as taking half of it, isn't it? Yeah, so it doesn't matter how I write it. So base times height, so which one is the base, which one is the height? It doesn't matter which one's which as long as you know that this one of these is the base and one of these is the height. This one right here cannot be base or height because it's not perpendicular to the others. Make sense? All right, so what do? 3 times 8 divided by what? 2. And then what's 3 times 8? 24. Or you could do this. You could go 2 goes into 8 how many times? Right? Or you could go 24 over 2. Doesn't make any difference. However you want to do it. And that's what? 12. Now, what if this was inches and this was inches? Oops. Inches. What would my units for my answer be? It's area. It's inches what? Squared. Area is always squared. Perimeter is just the units. Does that make sense? All right. So make sure that you get that. So that's what the area of this would be. And what if this was 3 and this was 8? What's the area of the whole entire rectangle? That would be 24, wouldn't it? Well, the triangle is half of the rectangle, isn't it? So does it make sense that this would be 12? Absolutely. Because if this made a rectangle, right, of 3 sides 3 and 8, then it would be 24. What's half of that? It would be 12. So this one would be 12, this one would be 12. Altogether, that'd be 24. Make sense? That's how you do area of a triangle. All right, that's not too bad. All right, got lost on my notes. Oh, there we are. Well, what? Converse. Oh, there we go. Oh my goodness, I'm out of control here. I still haven't found where I was. Where was I? This is crazy. It's like one of those times you walk in a room and you don't know why you went in there. Has that ever happened to you? Yeah. All right. Yes, sir.
I'm in worse trouble than you. I'm getting tests like this today. They're not in my Dropbox.
Oh, no. Yeah, that's not good.
Hey, take your time, Mr. Rose.
All right. I think I found where I was supposed to be. Let's do another geometry formula. Let's do a circle. Now, when we have a circle, let's draw a circle. I got a little thing right here. Boom, boom. There's a circle. Isn't that pretty? All right. So let's talk about this circle right here. We can also find the perimeter and area, but we have a special word. Instead of using perimeter of a circle, it's the circumference of a circle. Circumference. Okay, we're going to find the circumference, which means what? You start somewhere, right? And what you got to do is figure out what the distance around that whole entire circle is. All right? So let's do something before we talk about that. Let's put a little dot right here in the middle. What do you think we call that dot in the middle? What of the circle is that right there? It's the, no, not the dot in the middle. It's not a midpoint, it's the center. It's the center of the circle, okay? So we call that dot right in the middle. We call it the center of the circle. Now, if I drew a line, or a line segment, from one end of the circle to the other end of the circle, but it has to go through the center, we give that a special name. And I'll just keep it in blue. What do we call that? Starts with a D. Diameter, okay? That's pretty important. And there's something else that's pretty important as well. So let's do that in this pink color. Said you could see the pink. I'm going to start just from the center and go to, let's go over here so I can write it over here. See that pink one right there? That has a special name. What do we call that thing? The radius of the circle. Tell me something that might be true about the diameter and radius together. How do they, I can't think of the word. How do they relate to each other? Exactly right. The radius is half the diameter. Let's go the other way. The diameter would be what? Twice the radius. Would you agree with that? Okay. So we have a couple different ways that we can write circumference. All right. We talked about pi in here the other day, didn't we? Remember I talked about it had a circle and I wrapped a string around it and all that kind of stuff. So we talked about where pi came from, so I'm not going to do that again today. I did that actually in my geometry class this morning. We talked about that. So if I have an equation for circumference, it's going to be this. You could write it one of two ways. You could write it pi times the diameter, or since the diameter is twice the radius, we could say the circumference is what? Pi times 2r. But we don't write pi times 2r. It doesn't look that pretty like that. So what we do is this. We write 2 pi r. Just looks a lot nicer putting the number out in front, okay, and then the other two things next to it. So this is let's do this. This right here is basically your formula for circumference. You can do it either way, right? So if they give you a problem, they give you a diameter, just use this one, okay? If they give you the radius, just do this one. Basically, you just double the radius and multiply it by pi. What's pi equal to again? 3.14, okay? Approximately. Watch, I'm going to put a little squiggly right there. It means approximately 3.14 because it does keep on going, all right? So that's circumference. That's the same thing as perimeter, isn't it? Circumference is just another fancy word to mean perimeter. So that's how you do that. Now, let's talk about the area. And this is in length. Should I do an example? No, I'm just going to give it to you. Yeah, I'm not going to finish today for sure. That's okay. So we'll just take our time then. Let's talk about area now of a circle. So what is the area? The area would be all of this. How many squares can you fit inside of that circle? All right? So it's going to be weird because you got a curved area, don't you? So you have a little bit of stuff left over. That's why you're going to have weird numbers for this a lot of times. So how many squares could you fit inside of this circle? That's what area is. And here is your formula. It's pi, because it's a circle. You're talking about pi. And then it's the radius squared. Remember, area is always squared, isn't it? So that's one way to remember, because a lot of students get confused. Which one is which? Circumference is 2 pi r. It's just straight distance. That's all it is. Okay, it's just straight up distance. So if I ask you to walk around the circle, you would say, I walked around 27.32 feet, okay, or whatever. I'm just making that number up, okay? But it's just in feet. If I ask you the area, how many squares can you fit inside of this thing, all right? You might say 73.8 what? Square feet. I know that's a mess. Shouldn't have written it right there, but you get the idea. So this is always squared. Area is always squared. Perimeter is just the straight up distance, all right? It's either inches or centimeters or whatever, all right? But area is always squared. So let's put a box around that thing because that's super important right there, all right? So those are two main formulas for circle. And I tell you what, I'm going to stop right there because the other things that we do are three-dimensional. So I figure we'll just use 2 today for the two-dimensional stuff, and then on Monday we'll talk about the three-dimensional stuff, okay? I'm not officially assigning this homework. It's not really due on Monday, even though I probably said it was in the, did I say it was? Let me look at the, yeah, what did I say? Oh, I put the same exact homework down for Thursday and Friday, didn't I? This is what it's eventually going to be, all right? It's eventually going to be this. But what I would suggest that you do is go through the problems. I don't know which ones they are, but go through the problems, find the ones that we've covered today, get those done, and then on Monday I'll give you the rest, and then you can finish it up Monday night. You understand? So don't wait till Monday night to do all of these. All right, so it's page 36 and 37, and we're doing 11 to 43. We're just doing the odds. Okay, so that's the homework, and we're going to call it section 16A. Okay, so there it is. You may not get to all of these. Like, again, I don't know. I don't have the book in front of me. I'm not sure which ones are which. But there will be a point where they're going to get to three-dimensional objects, like a cube and a sphere and a cylinder. Don't worry about doing those. All right, again, I don't know which numbers those are. You have to look for yourself. But the ones where it's rectangle and triangle and circle, do those. You got it? And again, I don't know which numbers they are, but just do the ones that are two-dimensional. We'll leave the three-dimensional stuff till Monday. Everybody got it? Okay. Any questions? Any comments? Anything? All right, that's it. Yes.